Next, we're going to graph a piecewise function. Okay, so we talked about evaluating piecewise functions in the last section. These are functions where you have different formulas that you use to find your output depending on where you are in the domain. And you can have any number of pieces, okay, and anything for the functions. This is what I would call piecewise linear. Each piece is a straight line, which is going to make it a lot easier to do for a first example to think about what they're going to look like. But this graph, it's going to have two pieces. It's going to look like the line 2x minus 3 for all x values up to 2, okay, for x less than or equal to 2. Then it's going to look like the straight line negative x plus 1 for x is greater than 2. At what I call the boundary points, which would be x equals 2, here we have to put open and closed circles on the graph depending on whether we have the equality or the strict, the or equal to or the strict inequality. Okay? So what I need to do is make a couple of tables so I can get some points to plot and draw the picture. I always start with a vertical line at, in this case, x equals 2. I draw a dotted vertical line where the graph changes. It just kind of helps me see what's going on. But here on the slide, I started with the table. Okay? So I'm going to graph 2x minus 3 for x less than or equal to 2. Since I know it's a straight line, I only need a couple of points. And I need to make sure one of those is 2, whether that point's on the graph or not. This one is on the graph because it's for x less than or equal to 2. So I'm going to include my boundary point of 2. And then I need any other point that I want, and you can do as many points as you need, but it's a straight line, so I'm going to pick one point that's less than 2, so I picked 0. So I plug them in, it goes through 0, negative 3, and then if I plug in a 2, I get 4 minus 3 is 1. Okay? So, again, first thing I do, I draw a dotted line at x equals 2. That's my boundary. It's going to look like 2x minus 3 and have a slope of 2 until it gets to the dotted line, then it's going to look like negative x plus 1 on the other side. So I've plotted my points. I get just a regular point that I would plot at 0, negative 3. And then I'm going to put a big circle at 2, 1. And because I have the or equal to, that point's on the graph, we shade that circle in. Okay? And then I draw a ray, a half of a line, okay, with the arrow pointing off into the negative direction. Okay? So for a piecewise function, you have to graph them a piece at a time, so focus on only x values that fall in that region and plot as many as you need. For a straight line, we only need 2. We need the point on the line to know where to put this big closed circle, and then at least one more point, and I did the y-intercept there at 0, negative 3, and then draw the line in. We're going to have another piece, another line on the other side, negative x plus 1. So I make a table there, and I want values where x is greater than 2, but I also include 2. We're going to have to put a big open circle at x equals 2. So you always include the boundary points on all of these because I need to know where it hits the line. So if I plug a 2 into that, I got negative 2 plus 1 will be negative 1. Then I pick one other point, since it's a straight line, greater than 2, I picked 5. Negative 5 plus 1 is negative 4. So I plot those points, but the point at 2, the function value is the one that we shaded in from the other piece. I'm plotting this one for x greater than 2, so we put an open circle there at 2, negative 1. And then we have our regular point at 5, negative 4, and we draw our line in. Okay? So a little bit complicated here, drawing piecewise functions because you have to separate them into the different pieces. Piecewise linear is not too bad, especially if you just have two pieces. You need 2 points for each one. Make sure you include the boundary point on both of them because we need both the open and the closed circle to appear on our picture. It is possible to graph these on a calculator, but I say it's probably more trouble than it's worth. Okay? I always expect my students to be able to draw these things by hand anyway. I'll show you. Here's how, might as well. Here's how you graph them on the calculator as best as we can. So y equals, clear it out. You have to do the two separate pieces. If there's more than one term there, we need parentheses. So 2x minus 3. And then we're going to divide by, is the trick we can use on the calculator, the condition, x less than or equal to 2. And I need that in parentheses as well, so I do x. The inequalities are in the test menu, and I'll explain what they do here in a minute. But you do second and math to go into the test menu. It says test above it, and pick the one you want. Okay? And so that's how I'll enter it in. I've got my piece, 2x minus 3, in parentheses to group it, and all that divided by my condition, x less than or equal to 2. What it does, the test menu, it tests those x values and returns a 0 or a 1. When it's not true, it's a 0. You divide by 0, it does nothing. When it's a 1, you divide by 1 and get 2x minus 3. So it's going to plot exactly what I want. I'm going to do zoom 6. And there's that piece. Okay? The only thing it doesn't do for me is show me the opened or closed circles on the endpoint because it just plots the little points. Okay? For the other piece, in parentheses, negative x plus 1 divided by x, go into the test menu, second math, this time greater than, number 3 there, 2, and I get the other piece. Okay? It's doing the break there at x equals 2. So there should be a closed circle on the endpoint coming from the left side and an open circle on the right piece on the endpoint there. You can see in the table, if you do second and graph, you go into the table, you'll see if you go to x equals 2, you have a value for y1, which was the top piece, because 2, 1 is on the graph, but I have an error on y2 because that point is not on the graph. Okay? We can't see the open and closed circles, but that's the equivalent of it there in the table. So yeah, it's possible to do piecewise functions on your calculator, but again, I argue more trouble than it's worth. Here's where I drew it by hand.